Hello. In this video, I'll be going over a question related to the learning outcome. Describe the motion of transverse and longitudinal waves. The question comes from ACE Physics Syllabus Code 9702, Paper 12 from May-June 2014. Question number 24. It reads, the diagram shows a vertical cross-section through a water wave moving from left to right. At which point is the water moving upwards with maximum speed? So this question really illustrates that water is a transverse wave. Here they tell us that the wave is transferring energy from left to right, and they've shown us this vector here, so the wave is moving this way. The water particles are moving up and down, right, at right angles to the direction of energy transfer. This question asks us which of these points, A, B, C, or D, is the particle moving upwards with maximum speed? Well, because the wave is moving from left to right, in just a moment, point C is going to be at the crest, the place that point B is now occupying. Because point B is at maximum displacement, it's not moving with any speed. It's sort of reached its maximum displacement, and it has to turn around to sort of move back down. And so its velocity for just an instant is 0. In order for point C to get up to the crest where it will be in just a moment when the wave makes it there, it must be moving upwards right now. And in fact, it is the correct answer here. It is moving upwards with maximum speed because in just a moment the wave is going to kind of look like this. Point B will move down, point A will move further down to the trough, and point D will start moving back up here as the wave continues moving. So you can kind of sort of imagine what the wave would look like in just a moment. And clearly point C is going to be that point, which is occupying the crest position. So in order to get there, it's got to be moving upwards, right, with maximum speed. Point D, like point B, has a speed of 0. It's sort of just reached the trough, and then it's going to be moving sort of back upwards as the wave moves from left to right. So that kind of brings us to the end of the worked example questions for all of the first 5 learning outcomes related to waves. The next question, which I want to go over right now, is the introduction to the next set of learning outcomes which relate to wave superposition. And so this is a good sort of segue here. This question, which is question 25 from the same paper I just mentioned a moment ago, reads, the principle of superposition states that a certain quantity is added when 2 or more waves meet at a point. What is this quantity? That quantity, I'll just tell you, is displacement. Since we haven't gone over it yet, displacement is the quantity that is added when 2 or more waves meet at a point. And in fact, you could maybe restate that in your own words and kind of use that as a definition for stating the principle of superposition.